We're discussing on Introduction to Robotics and IoT with reference to Arduino. Today for this webinar, Mr. Rinaldo Hira, who is presently working as robotics trainer and mentor in adult tinkering labs under NITI Aayog. But before proceeding to the webinar, I would like to give you some information about Royal Global University. Royal Global University is a university of Northeast of India, committed to provide unparalleled education to render holistic development of students. It has 37 schools from one courses located at one location of Guwahati. Our is spread over 7 acres of land, which is about 12 hectares field of area. Campus well maintained and facilitated with world-class infrastructure. One of the strongest of our highly qualified and well-experienced faculties led by Professor S.P. Singh sir, Vice Chancellor of RGU, to take care of more than 5. I also feel privileged to say about our Honorable Chancellor, Professor S.P. Singh sir. Professor S.P. Singh is a well-known academician and administrator having dynamic and enterprising personality with more than 39 years of experience in teaching, research, and academic administration at various institutes of repute. Professor S.P. Singh sir has been associated with the Royal Group from its inception in 2009 as the founder director of the institution. He further moved to MIT Education Group in 2013 and joined as the Senior Vice President Academics of the group and was responsible for functioning of 6 MIT campuses located in different parts of the country and abroad. Suarez joined the Assam Royal Global University in November 2016 as the founder vice chancellor with the power of speaking, sir. The university has been ranked the #1 private university of Assam by for the span of just 3 years. Mr. Rinaldo Hira, I take the opportunity to introduce him to all the participants in this webinar. He is presently working as trainer and mentor in adult tinkering labs under NITI Aayog. He was former Indian Gurgaon, was also a network engineer at ACL Technologies, robotics engineer and mentor at Academy of Robotics Guwahati and Vizag, and robotics engineer at STEM Robo in Noida. Now, I would like to request Mr. Rinaldo Hira to kindly begin students today's session on the interesting topic, Introduction to Robotics and IoT, with reference to Arduino. Sir, please. Sir.
So Ashok sir, all I will explain my present here. Or
It's not audible.
Yeah, am I audible, sir?
Yeah, perfect.
Thank you. So first of all, I would like to express my gratitude to Arju and all the participants, those who are here, and I am very overwhelmed with this introduction and to be a part of this webinar. So robotics and IoT, these are actually very exciting and very very energetic things at this point of time, right? So as we all know that every one of us actually living a life full of technology. From the time we get up from our bed till the time we go back to our bed, actually we are surrounded by technology. We are surrounded by internet and a lot of things, right? So basically what we do is in this webinar I'm going to talk about introduce you to the platform that is robotics and IoT, right? These are actually very vast topics. These are actually vast fields. People invest many years to learn these things, but scaling it down to a session of around 30 to 40 minutes is actually a very tough job. But I'd like to thank Ashok sir and Avijit sir for giving me this opportunity and telling me how to handle this thing. So I have scaled it down to everyone so that anyone who is even at the level of zero, who doesn't know anything about robotics and IoT, can actually dare grab something from this, right? So, without wasting much of your time, I'd like to start my session. So, as I have already told you that we all are living a life full of technology, and robotics and IoT is now two grooming fields at this point of time, right? So, robotics is basically the study of robots, and IoT is something related to internet. All right, but why these two topics are brought together in this platform? Because robotics and IoT are actually connected to each other some way or the other, right? So let me first start with robotics. All of us has seen robots, maybe in movies, maybe in televisions, maybe in some reality shows, maybe in news. So all of us have actually seen robots. So basically, a robot is interconnected machines with circuits, with some programming and some sensors, right? So when we used to think about robot in our childhood, or maybe you were, first thinking about robot, first thought of robot that comes to mind, structure which looks like a humanoid. I mean, looks like a human being, and it has mechanical structure with some, glowing eyes and having a very weird kind of movement. But now, robot is not restricted to only a specific size or shape, right? Robots, you might see a robot which might look like a bird. You might see a robot that might look like a snake. You might see a robot that might look like an insect, right? But all the robots work under some configurations, some protocols, right? So basically, when we dig inside a robot, when we go inside a robot, we find some very important and functional things without which the robot will not work at all, right? Be it a very small robot, be it a very giant robot, right? So those functional units are, as you can see on the screen, they are a microcontroller, some sensors, some actuators or motors. Then there's something called AI, then a power supply unit. Now I'll show you how these things work.
Sir, sorry, sir, your the PPT is not visible, sir.
I'm sorry for that. I'm sorry for that. I'm sorry for that.
Okay, sir, no issue, sir.
Yeah, yeah. Visible?
Not yet visible.
Is my PPT visible, sir?
No, sir. A couple of
Okay, sir, just give me a second. I'm just facing some problem with the system. Uh, a bit.
yes,
Sorry
sir.
for that. Yeah, yeah, yeah. I guess it's visible. Is it visible, sir?
Not really.
20 seconds.
Visible. No, it's coming. It's coming. It's perfectly coming.
Yes, it's coming.
Okay, thank you so much. Yeah, sorry for that. So basically, as I was saying, that main functional unit of a robot are sensors, a microcontroller, some actuators or motors, and power supply, and the entire thing is supported by something called AI, artificial intelligence. All right. So now let me tell you that we can actually uh, compare a robot with a human body. All right, because robots were designed to replicate human being. Later on, people started replicate animals, people started replicate birds, people started replicate insects even. Right. So the uh, initial concept was replicate a human being. So we can actually compare a robot with a human body exactly, because a microcontroller is basically is the brain of the robot, right? So like we have a brain, and we control the entire body with the help of the brain. Like the brain controls the entire body. So the microcontroller is the brain of the robot, right? Similarly, if you see how these things are connected, as you can see, these arrows are showing you how these things are connected. So microcontroller is basically connected to everything. Okay, so sensors are input devices, actuators or the motors, they are the output devices, right? So basically, when you see a sensor, you can actually compare those sensor with the human sensing organs. Like we have 5 sensing organs: ear or nose, eyes, skin, tongue. We can compare those sensing organs with the sensors. Okay, our robots, all the robots have sensing organs in the form of sensors. So I'll give you just a very simple example. Suppose I'm trying to throw a ball in your eyes, on your face. Okay, suppose I'm trying to throw a ball on your face. So what will you do? Your first instinct will be duck. Okay, either you will duck or you will try to catch the ball, right? So how does it happen? So when you see that I'm trying to throw a ball on your face, your eyes detect. So that means the sensor does that sensing part. That means some obstacle is coming towards me. So within milliseconds, your eyes send a signal to your brain, and the brain decides what to do. If you're confident enough to catch the ball, you will catch, because you will be able to judge at what speed the ball is coming. Okay, so that is what a sensor does, and that is what the brain does. And the brain sends the instruction to your hands to catch the ball or you duck. So this is how the robot exactly function. All the inputs that are coming from the external world are analyzed, are checked by the microcontroller, and after that, it takes a decision what to do. But okay, now the actuators or the motors, they can be compared with the hands or the legs of the human body. Okay, so I'm comparing those things with a human body so that uh, you can understand it very properly. Okay, even if you're new to this field, okay, maybe there are some people who are from the different background like civil engineering or something, so it will be very easier for them to understand how the robot works, right? But there's something different in a robot than a human body: the intelligence. Robots do not have intelligence actually. Basically, in general, they don't have intelligence. We have our intelligence inborn. We develop that intelligence. We develop it during our growth. Okay, we get the information from the external world. We get the information from our family, from the locality, from the place we live, and we build our intelligence. And it is genetic actually. No one needs to do anything in our brain. Everything happens genetically. Generally, it happens. But in case of a robot, humans create the intelligence. So it's a man-made intelligence that is called artificial intelligence, right? So AI is now a very trending word. All right, you will get to hear these things, every electronic shop nowadays. Okay, if you go to buy any kind of electronic gadget or appliance for your home, then you hear this word, artificial intelligence, AI. What makes AI so trending? Because AI is something that is man-made, but it has actually overtaken the other technologies. How? AI is capable of taking its own decision. So this is how AI is helping the robot to take decisions when it's a time to take the decision for the robot, right? So now every robot needs a power supply. This is a very important unit. All right. Now to get deeper into robotics, I need to tell you about sensing, right? How a robot sense. Okay. So a robot basically sense in multiple ways, multiple things. It can actually sense the entire world. It can nowadays robots are sensing almost everything that is possible, right? Like we human can sense a lot of things: smell, taste, temperature. We can sense obstacle. Similarly, a robot also can sense a lot of things. Okay, a robot has capability of sensing obstacle. It can sense sound. It can sense light. It can sense temperature. It can sense moisture. It can sense pressure as well as gas. All right. So a robot is equipped with such type of sensors, which makes the robot, capable of interacting with the external world. Right. So now in today's session, I will be taking both robotics and IoT together. Okay, parallelly I'll take it to the end because robotics and IoT are connected, in a lot of ways. All right, as I have already told you. So now, uh, this was just the ice-breaking concept of robotics. Now, if we look into something called IoT, Internet of Things, right? So IoT stands for Internet of Things. So it's interconnection of devices basically. IoT is interconnection of devices. You can take example of uh, your ACs, the air conditions that you control with your smartphone. You can think about a smart car which is taking you to the shortest route. You can also think about your Fitbit, the smartwatch that is actually keeping the track of your daily activity, how many steps you are taking, what is your heart rate, right? So that is what we call IoT, Internet of Things. So IoT is basically, it's a game of data. You can say it's a game of data. The sensors are collecting data and it's feeding into a cloud, right? And we are accessing it from our smartphones, from our smart devices. So this is what we call IoT. But IoT has many layers. All right. Basically, it works in three layers. Okay. There are sensors, there are network, there are devices. Right. So what happens is basically you can see the extreme left hand side. I'm showing the sensor. So there are some sensors, temperature, lux, motion. So every sensor has a gateway. Okay. So gateway means you can send interface, send the data to the cloud network. Right. Now, cloud is something that is actually virtually present. Okay, we can say it's a database. So the data from the sensor goes to the cloud through the gateway, and it gives access to the people who are using it. So this is actually a very I have scaled it down to layman concept. So this is how IoT platform basically works. Right now, um, if you go for like if I like try to elaborate in a broader way how IoT works, just have a look. If you are talking about air conditioner manufacturing company, okay, so AC manufacturing plant, okay, so just to make you understand properly how IoT works, this is an example. So there is suppose a one air condition manufacturing plant. So to make actually to use less human in the industries, we have implemented IoT, Internet of Things, right? So the sensors are there in the manufacturing machine, the sensors are there in the county, all right? So what happens is the sensors are keeping a track and it's sending it to the manufacturer, okay, how many units are being produced, okay? And what happens is every manufactured AC has got one barcode. Okay, it has got a barcode. So what does barcode do? Basically, barcode gives one unique identification to every product, right? So all these barcodes are actually scanned by the sensors, and that unique ID or the specification of the device is stored in the cloud. All right. Now manufacturer can again access that. All right. Now when those products are shipped, They are sent to the retailers or they are sent to the wholesale markets. What they do is they again scan those devices and keep in their inventory. So in that case, what happens is the um, the main database of the manufacturer gets an update about the inventory. Okay, like where my products are going. I'm producing it in Guwahati and where I'm actually transporting it, where my products are working. Okay, so they get the entire update and how many retailers, how many showrooms their products are there. Okay, just by sitting at one place. They don't need to send people, they don't need to call anyone, they don't need to text anyone, they don't need to mail anyone. Okay, so we are actually decreasing human effort in all the directions. Now, next level, I'm telling you. Now, suppose the retailers started selling the products, okay, and they keep a track, okay, how many products they have sold. Okay, so before they sell, after every sell, they again scan the code. Okay, now again, what happens? The inventory gets a minus. That means the manufacturer comes to know that last month this retailer has taken 100 pieces and he has already sold 80 pieces, so 20 left. That means he needs to get his second lot ready. Okay, so this is how IoT works, Internet of Things. So the main concept is decreasing human effort and saving time, right? So now the next level is the air conditioner is equipped with a sensor. Okay, it keeps on monitoring how the air conditioner is working, how the air purification is happening, what is the health of the device. Okay, now that sensor communicates with the cloud again, right, of the manufacturing company. So what they do is when your air conditioner needs a service, the customer care will automatically call you. You don't need to like call someone, or you need to open your air conditioner to try to fix it up, or you need to even before you know that your air conditioner needs a service, the manufacturer will know it before you. So this is what the next level of IoT. Understood? So now why this thing is very important at this point of time, as we like this is one of the million examples of IoT. Now we have smart devices, so we have smart cars, smart homes, and smart cities as well. Right now, it has made our life very convenient. Right now, if I talk about the future of IoT in 2020, it was assumed. It was uh, recorded that 24 billion IoT devices were already in the market in the entire world till 2020. All right, and if you talk about the revenue generated by the companies, okay, IDC predicts that uh, before till 2090, $357 billion was already uh, revenue from the IoT market. Now you think about it, what it's going to do next. So that is actually it's creating job opportunities as well, right? So being an IoT specialist, you can actually have a good career in the future, right? So next thing that I want to talk about is IoT in agriculture, right? So now IoT has actually not only touched the industries, it has also touched the agricultural fields. Recently, I have developed such a similar project. Okay, I'll talk about that later on. But let me first tell you that how this thing can help you in agriculture. If you have a plant, okay, you can just check that left picture. Okay, it's just showing a sensor put in the soil of that pot, and it's connected to a device. And do you know that you can actually pick up your phone and you can check what is the health of that plant? How? So there's a sensor which is called soil moisture sensor. The soil moisture sensor actually gets the data about the soil. What is the moisture level in soil? What is the toxicity level? Okay, so it gets to know about the soil condition, and it keeps on sending the data to the cloud. And you can anytime you can just pick your phone and you can check. Okay, when do I need to plant my water my plant? When do I need to do some irrigation in my crops? Okay, so now everything is monitored by the IoT platforms. So there are a few new things in IoT which has happened recently. There's a collaboration between Levi's and Google to invent something called internet connected jacket. Okay, so it's like you can say your body uh, caretaker. Okay, the jacket takes care of your pulses. The jacket takes care of your heart rate. Actually takes care of everything, your body temperature. So this is actually collaboration between Google and Levi's. So we all know Levi's, right? And we all know Google, and they are in everywhere. Actually, Google is everywhere, even inside our house. So they have invented something called a internet connected jacket, and you can even receive phone just by moving your right hand. You can play music just by shaking your left hand. So this is what technology has gone into a next level. Okay, next thing is home automation. IoT has actually done a revolution in home automation, right? You went to your office, you forgot to switch off your fan, you forgot to switch off your oven, forgot to switch off some appliance. What will you do? You can't come back. So you can do everything from anywhere. Even if you are in United States, you can turn off your TV from US without even taking more than 2 seconds. This is what IoT has done to us. Okay, if you are coming to your home and you are at your main gate, you don't need to step down of your car and you need to just go and open your gate, or you need to call someone or into your watchman to open the gate. When your car arrives, your gate automatically knows that it's your car and it needs to be opened. That's what IoT is doing. Okay, now smart doorbells are there to take care of your house when you're not there. Okay, it can keep a track how many people came when you were not there. Now there's something very important that we call air quality monitor. So air quality monitors are very important at this point of time because we are living in a world full of pollution, right? So sensors are put in public places which keeps on gathering the data. They are basically air quality sensors or smoke sensors which keep on getting the data from the external world, and it keeps on uploading the data to the cloud. If anyone comes to that place and open that application, they'll come to know whether the air in that place is breathable or not, or it will show you how much percentage of oxygen is there, how much percentage of carbon monoxide is there in that area. So this is how IoT is helping us in our day-to-day life, right? Now, a backbone of IoT. Okay. So without sensors, neither robotics can do nor IoT can do. Okay. So as we all are learners, we need to first learn how to develop some robotic projects, how to develop some IoT-based projects, right? So sensors are unavoidable parts of both of these fields, robotics and IoT. Okay, so here I'm just taking some examples of some basic sensors which you need to learn and you need to start with. Okay, so the number one that you can see is a sound sensor. It has a mic-like structure which can um, grab all the sounds playing around it. Okay, so there are a lot of basic toy cars and toy devices available, and you'll see some Chinese products like clap lights. You must have, all of you, like many of you must have seen clap lights. If you clap, the light turns on. If you clap again, it turns off. So this is the sensor which works behind those kind of devices, right? Number two is temperature sensor. Okay, the name of the sensor is actually, technical name of the sensor is DHT11. Okay, this is basically used in temperature and humidity checking, right? So this is basically used in temperature control devices. Suppose you want to control your AC with the outside temperature. Okay, if the outside temperature is this, I want my inside temperature to be this. So to program that, you need this kind of sensor. The third one is actually very little, very tiny, but it's very useful. Third one is called a LDR. Okay, it's basically a light sensor. The name of the sensor is LDR, light dependent resistor. Okay, those who are from the electronics background, I'm telling you, you will already be knowing these things, or maybe you have used it, right? So basically the BTech electronics people or triple E or EC people use them in they start using them in a final years projects or something. Okay, so this third sensor is called light dependent resistor. Okay, so what it does is basically this is a resistor, so it responds to light, right? So recently I've designed one device. Okay, you can I'll tell you honestly, like it can control my room's curtain depending upon the sunlight. So whenever sun rises, my curtains automatically opens. When the sun sets, the curtains automatically turns off. So you don't need to do anything. Understood? So this is what the sensor can do. Number 4 is called a gas sensor, or it is also called a smoke detector, smoke sensor. Okay, it has many versions for many different gases. For carbon monoxide, for nitrogen, for carbon dioxide, for other gases, it has different versions. So this is basically called a smoke detector or gas sensor. Okay, it has capability of detecting different gases, like sensing the carbon dioxide level, sensing the CO level in the atmosphere. Right, you can even design a fire alarm with this, Okay, now number 5, it's widely used and very famous, and many of you must have already seen it. This is called ultrasonic sensor. Okay, so from its structure you can actually assume why we use it. So basically it looks like two eyes, right? So, and it actually works like eyes. So basically ultrasonic sensor works in the principle of ultrasound. As we all know what ultrasound is a sound whose frequency is above 20,000 hertz. So it is actually not audible to human ears. It's audible to some animals, and if you wear some kind of ultrasound devices, then you can hear those sounds. Otherwise, you can't hear ultrasound. Its frequency is more than 20 kilohertz. Okay, so there's two structures: one transmitter, one receiver. Receiver, so the transmitter transmit the ultrasound and it strikes the object and it comes back, right? So when it comes back, the sensor comes to know that there is some obstacle present. It can even tell you the distance, okay, and it can even tell you if it is approaching. All right, so this is what ultrasonic sensor works. This is basically used for designing robots, ultrasonic robot. At the end of the session, I'll tell you how we can design a robot with the sensor. The next two sensors, 6 and 7, both are actually called infrared sensor. Okay, so first one is called PIR sensor. That is pyroelectric infrared sensor or passive infrared sensor, and the last one is called infrared sensor, IR sensor. So basically, it uses infrared to transmit and receive. So it's very simple. It works like the number 5. In number 5, it uses ultrasound, but in both of them, it uses infrared light. So infrared light is a light which comes under visible spectrum. Okay, so now there are some basic sensors. Okay, but there are, in robotics and IoT we use some advanced sensors as well, right? So the first one that you can see, this one, the board, this is called a gyroscope. Okay, now a gyroscope sensor, this gyroscope is actually very famous among the people. Okay, because with the revolution of smartphones, gyroscope has become very famous. Otherwise it was a very high-tech product. Okay, it's now, and even the people who play a lot of PUBG, they know what is gyroscope is, right? So gyroscope is something, it's something that is related to the uh, earth. Actually, what happens is whenever you're rotating your device or you're shaking your device knows that you're moving it with respect to the gravity, with respect to the earth's surface. You're tilting it, then it comes to know that it's working. I mean, it's being tilted. So whenever you're watching a video in your phone, if you rotate the phone, the display automatically turns. It automatically rotates. So that is the function of a gyroscope. The next sensor I have already told you in agriculture and IoT. Okay, this is called soil moisture sensor. Okay, so this is the sensor that we use for soil monitoring in IoT devices, right? And the next one is called a flex sensor. This flex sensor is basically used for designing robotic arms. If you want to design a replica of your hand, you can do it this. How it does is, if you band this sensor, it sends different values, and taking those values, you can control the motors, right? So these are different type of sensors, right? Now you are now you might think that, okay, now what are the things apart from this we need to know to start learning robotics or IoT? So there are a few things, there are three prerequisite knowledges that you are supposed to have before you start with robotics and IoT, right? The first one is basic electronics. It's very important. So basic electronics is the skeleton of any robotic device. This is the skeleton of any IoT device. So basic electronic includes a lot of electronic components which all together makes a circuit, like resistors, capacitors, transistors, and then switches, wires, potentiometers, sensors, all are included under basic electronics. All these electronics are actually basically they are semiconductor devices. Okay, so you need to learn how to use those things and how you need to connect those things in a circuit. So the next thing that comes is sensor knowledge. So you need to also learn about sensors. Okay? How a sensor works, how a feedback works, how you can program a sensor. Then next thing comes is circuit designing. So after you know basic electronics, you are actually good to go for circuit designing. Okay, you can design basic circuits. Okay, next thing is basic coding, right? So circuit designing gives you hardware, like it gives you the hardware, but basic coding is something that you need to create the intelligence. So without that, IoT and robotics is incomplete, right? Now, I'll show you how you can design a circuit, a basic electronic circuit, right? So while designing a circuit, there are basically three things that come. Okay, first of all, schematic design. Then you need to do a breadboard circuit. Then the next thing is a PCB circuit, right? So basically, schematic design is something like when an engineer makes a house, he makes a design either in paper or in software, right? So we also do the same thing. Okay, before you make circuit, you need to go for this, right? So before you make the circuit in physical structure, you need to make the schematic design. Okay, so after you make the schematic design, you need to go for something called breadboard circuit. So the white stuff that you can see here, the white board, it's called a breadboard. Now, why do we use breadboard? Breadboards are basically used for plugging in and plugging out the devices. So it's for beginners. Okay. Now we go for PCB circuit. Okay. PCB circuit is the solid circuits that are actually done after you learn the breadboard circuit. Okay, now in the future if we get some if you get opportunity, then we will discuss all these things in details, but you need to keep in mind that before you go for PCB circuit designing, you need to learn schematic design and breadboard circuits. Okay, because if you practice breadboard circuit properly, then you do not make any mistake in PCB circuit. And because in PCBs you cannot rectify, if you solder one PCB, it's very hard for you to remove, and it creates a lot of error in the circuit. So that is why breadboard is necessary. So I'll show you a breadboard also how it looks like. This is how it looks like. Okay. So all the pins can go inside it, and whenever you think that there is some error or problem, you can just plug it out. You can pull it out. That's it. So it's very easy for a beginner to start with the circuit. Right. So this is how a breadboard works. Right. Now, title of this webinar was Robotics and IoT with reference to Arduino. Now, what is Arduino and why Arduino, right? So Arduino is basically a development board. It's a microcontroller board. I told you that a robot or an IoT device has a mechanism which is the sensors are controlled by a microcontroller. So Arduino is a microcontroller board which is the best prototyping tool for the beginner. So even I personally recommend to use Arduino for the beginners because it's very easy to learn and it's very easy to start with, right? And it's the best prototyping tool and it's actually convenient for beginners. And the most important thing about Arduino is it's open source. So when we say open source, it's a product which is open source. So you don't need to pay to learn Arduino, right? There are a lot of forums available in internet. They have official websites helping you in programming, in like starting from scratch, right? So that is why Arduino is very famous. Basically, it was Arduino actually came into the picture 17 years back in 2003, but in India it has become famous in last 5 to 10 years. Okay, still a lot of people have not heard about it, but this is actually a very famous prototyping tool in the field of robotics and IoT. Right. So now I'll tell you a little bit about our board. Okay, this is how the board looks like. Okay. Basically, it's a microcontroller based development board. So as you can see, there's a black long thing in the middle. Okay, so that is a microcontroller. That is a microcontroller. Its name is Atmega 328. So that microcontroller does everything to the devices that you connect. And from the top right hand side, you can see a rectangular shaped plug that is actually used for connecting this board to the computer. So basically, we do the programming in computer, we connect it, and we upload the code, right? And from both the sides, you can see there are a lot of pins. Okay, some pins are for input devices like sensors, some pins are for output devices like motors, actuators, all those things, right? So this is the pin description of Arduino, right? Next, there are some other versions of Arduino. Okay, the first one that I have showed you, okay, that I have shown you, this one is called Arduino Uno. I have already written it there, Arduino Uno. Uno is the widely used version, and this is actually easily available and it's easy to learn. And uh, in case of Uno, the circuit designing is very, very easy. Some other versions, the first one is called Nano. It's very small. The biggest one, the smaller than that one is called Pro Mini. Okay, and this is the Mega, and this one Leonardo, and this is the Lilipad. So why I'm showing all these versions is just as an introduction. Okay, that Arduino boards, microcontroller boards have many versions. All right, and depending upon a device you are designing, you can pick your own choice. Right. So next is something that we can talk about. Okay, that is IoT chip. So this also belongs to Arduino family. This is called a Node MCU or ESP8266. So this is uh, actually very small. As you can see in the left picture, how small it is in comparison to your fingers. So this is basically used in wireless communication. Okay, that I was telling you to how you can monitor your crops, how you can monitor your plants from anywhere. So this is what the device we connect the sensor to. This is called Node MCU. Okay, this again supports the same programming that the Arduino does. Right. The next thing is very important. Okay, as you can say, like without programming, we cannot actually design anything. So basically, when we say program, a program is a set of instructions. Okay, so we are giving set of instructions to a microcontroller what to do. I'm actually teaching like a baby. Okay, that if you see this person, you need to say this. If you see this person, you need to say this. Okay, like we teach our small babies, right? That if you see uncle, say namaste, like this. So this robot is also working same phenomenon. Basically, we write some instruction and the robot performs accordingly. Okay, so to uh, write programming we use some softwares or some integrated development environment that's called IDE, where we write the program. Okay, so what does IDE basically do? So this is how the Arduino IDE looks like. So when you connect Arduino board to a any computer, you will you need this software to write the codes. All right. Now, what does IDE actually work for? IDE is something that converts our language into machine language. Okay. So basically, what we do is we write the code and upload this code to microcontroller. Okay. But the microcontroller does not understand English. As we all know that it works on digital data, ones and zeros, binaries. So when we write the code here, we compile it. So while compiling, the code gets converted into digital data, discrete data. Okay, it gets converted into binaries. Now it gets uploaded through the USB to the microcontroller. Be it's a robot, be it's IoT device. Okay, you need to use a programming language. So this is Arduino IDE, which is basically based on embedded C programming. So this actually, you can say child of C. Okay, it's related to C only, but it is called embedded C because this is specifically designed for robotics, right? So, but many people who does not have a coding background and they want to start with robotics. What about them? Civil guy or maybe a mechanical guy. Maybe he does not have a coding knowledge. Does not know what is C. He does not know what is Java. So how that person is going to start with coding? How that person is going to start with robotics and IoT? There is one more option. So that is why I recommend Arduino. Arduino is having one more programming language that is called a modkit, or it also having something. Many of you are actually familiar with this kind of coding, okay? Because you have seen a lot of babies doing Scratch programming. So Scratch is a programming language which can do wonders to kids by drag and drop programming. So Arduino has replicated that thing and brought this platform for those who are having zero knowledge in coding. They can even start. Okay, you can drag and drop and do the Arduino coding, and you can design your own device. All right. So I'll now give you some examples of robot that we can actually design in our first 3 months of learning robotics or IoT. Okay, so this is called a surveillance robot. It is actually equipped with a camera and ultrasonic sensor. So it has a radio transmission channel which can do a live streaming, and it can actually be used as a surveillance robot. Now, this is something which is very common. Many people design it. You'll see engineering students designing this for their like as a first robot. This is an obstacle avoiding robot that is using a sensor. The sensor is familiar to you. Okay, this is called an ultrasonic sensor. It can detect obstacle. It can even move his head. Now, this is something very interesting. Robotic arm. This is also a very revolutionary Arduino design. Okay, it's called a pick and place robot. If you don't want to like do anything, you can just sit and get some work done by the robot. It will do it. It will pick something and it will place at the desired place. Right. So now the last one. This is called a Craybot. Okay, this is also a beginner's project. Okay, you can start building this after you learn how Arduino and ultrasonic sensor works. Okay, this is a robot that can walk with its 6 legs. It uses 6 motors which can make its 6 legs move, and it can change its direction when it sees any obstacle in front of it. Right. So this was all about robotics and IoT. All right. Now I'd like to show you one very small video. Okay. So this will actually show you how you can create your first robotic project after learning your basic electronics and basic sensors. All right. So this is called an obstacle avoiding robot. Okay. So just watch this video. Okay, so ladies and gentlemen, so this was all about Arduino and robotics. As I have already told you that these are so wide fields that I could just give you a very ice-breaking concept of these two fields. So there are a lot of other things like machine learning and deep learning. Okay, where you need to use different kind of programming languages and different kind of hardware knowledge. So this is just a basic concept and basic idea about robotics and IoT. Okay, so Ashok sir, this is like I'm done with this.
Okay, sir. Thank you, sir. It
Yeah.
was such an engrossing and interesting session. I'm sure that all the participants have been enriched from your deliberation today. We are also being privileged to have amongst us Honorable Vice Chancellor Sir Professor S.P. Singh sir and Professor Alok Boragohai sir. Sir, we would also be privileged to hear from you, sir.
Thank you, Ashok Talukdarji. A very good morning to all of you. I was there from the very beginning. I joined dot at 10 a.m. and I was very, very patiently listening to Mrinal. Thank you so very much, Mrinal. It was really a fantastic journey for of last 50 minutes. And I think I have learned many things about robotics and IoT. That is not my field at all. But then in the day-to-day life, we deal with many situations, many things around us. We watch many movies. We are futuristic. We think about new things coming up, which probably will help the mankind, humankind, and also at the time of pandemic, corona times, and many things are helping us with which we scientists, you scientists have developed with respect to robotics and IoT. And it was a very basic concept clearance, I would say, session, spreading out how to go about it. End of the day, how can you be ready for making one small robot with using IoT? I would like to say only two, three things about what I know a little bit about. I mean, I heard something about Malaysia Automotive and Robotics Institute. In the Malaysia, we have Automotive and Robotics Institute. They are doing a great job with respect to, I think, IoT and robotics, and especially in automotives. I think I just presume that the way life is going for all of us, one day we will be working in the office and robot will be working at home. And if robot is going to work at home while we come back home, everything is ready for us. Dinner is laid down on the table, and everything is ready, and we are ready to sleep. And after we leaving the home, he is finishing off the home. I mean, that kind of concept we see in movies, and that will come one day. And that can only happen, I think, probably, which I can recall, because robotics is basically, in my opinion, which work on anticipated situations. I mean, in robotics, we have some anticipated situations, and real action has been done by robots and robotics. And IoT is basically can handle well-defined tasks, which we well-defined it, and then it is a sort of support mechanism or information mechanism and communication mechanism with the robots. And if they join hand together, which is happening very fast, and we are seeing everything happening. And if you want to manage your robots from remote, and that is through internet, we have no other option but to use IoT, in my opinion. I don't know, my little knowledge says that, because only then you can do that. So these are a few important things, and I think something has emerged out of this is called Internet of Robotics things. I mean, not IoT, IORT or something like that. Internet of Robotics thing, and that is actually emerging very fast. And I would say that whatever you spoke today, it was related to IORT, and I think it was a fantastic presentation and fantastic journey so far. And I hope many of my students must have raised many questions, and you will be able to answer them. And that's all. I think I should not put my nose into your area of domain, but little bit information and knowledge what I have I shared with you. I'm very hopeful that your field and my professors in the institute will come into contact with you. You're working with Niti Aayog right now. You worked many institutions of robotics earlier, and if something can be done in association in Royal Global University, we will be, because this is your place, your institution, your university. If you will help these guys to do something really concrete in this field, I will be very happy to associate. Thank you so much, everyone. Thank you,
Thank you, sir.
Mrinal, and thank you, everyone in the Mechanical Engineering Department, Royal School of Engineering and Technology.
Yeah, thank you, sir. Thank you, sir. Sir, we are also privileged to have amongst us Professor Alok Kumar Boraga, sir. Sir, we will be privileged to hear from you, sir.
Hello, can you hear me?
Yes, sir. Yes, sir. You're perfectly audible.
Can you,
Yes, sir.
so you have already heard a very beautiful presentation by Mr. Hira, a young engineer, and also you have heard the comments from our esteemed Vice Chancellor, and I do agree with him. And I was also there right from the beginning, from 10 a.m. till the end, 50 minutes of such an engrossing and engaging presentation. Even though he is saying that it is ice breaking, I think it is more than ice breaking because of two things. One, I must appreciate the kind of lucidity, the kind of ease, the kind of effectiveness with which he has made the presentation. It's a very brilliant, presentation in terms of explaining to the students. I'm sure I know what you are doing right now. I forgot, but then you are an excellent teacher material. Let me put it on record. And secondly, as far as the technology is concerned, you know that this technology is both transforming and empowering us like anything, especially now in this COVID pandemic situation, when we are all getting used to a new ecosystem of working from home, remote working, remote interactions, and doing everything digitally. I think robotics would add a very new dimension to our lifestyle in the near future. Already there is a talk about driverless vehicles and all that, IoT, artificial intelligence, everything coming together. So it is a very good example of how multidisciplinarity in engineering and technology can lead to. And I really thank you for your brilliant presentation. I'm sure our students and young faculties are benefited tremendously. And I wish you all the best. Thank you.
Thank you, sir. Thank you, sir. Mrinal, sir, we are having some questions.
Yes, sir.
So a question is there from Mr. Hirakanjan Das. So his query is, can we make temperature visualization system using MLX 90614 sensor?
Temperature visualization system.
Yeah.
Can you repeat the question, sir?
Yes, so the question is, can we make temperature visualization system using MLX 90614 sensor?
Okay. So yeah, it can be done. Basically, actually, what happens is MLX that 90614 sensor. This is basically used for like it's a infrared based sensor. Okay. So as I've already mentioned in the basic sensors about the infrared sensor. So it is actually a it's called a non-contact infrared sensor. So basically what happens is like you have seen those nowadays like COVID patients or like anywhere in the shopping malls also you can see those IR thermometers, as you can see, like gun thermometers. So those are also the like product of MLX 90614. We can definitely design if you get that sensor in loose somewhere, get it, and you can just do the PCB designing with some microcontroller. It's not that you have to use only Arduino. You can also use Raspberry Pi. You can use ARM or Cortex. You can just connect it, and then you need to do a very basic programming. If you just want to get the temperature, then it's done. It can be done. Just you need a LCD display to display your data. Yeah, it can be done. Yeah. Sir, your voice is
his question is
breaking.
Okay. The question is, what is advantages of circuit pattern in IoT?
Sir, could you repeat? Your actually voice is a bit breaking a bit.
Circuit pattern in IoT.
Actually, you're not. Oh. Yeah. Now I can hear you. Yes, sir. Yeah, now you're audible.
Yes, sir. The question is from Ilahi Barbuya, sir. The question is, what is advantages of circuit pattern? Advantages of circuit pattern in IoT?
Advantages of circuit.
Python in IoT.
Okay, circuit in Python in IoT. Okay, so like I could not hear you completely, but yes, what I have made up is like he's asking something circuit related to Python.
Yes.
Yeah. So yeah. So what is
Ashok,
like?
may I?
Yes, sir, sure.
Your voice is cracking, so may I? Ashok, Ashok, it's
Yes, sir.
Shomobrata here.
You can take it.
Yeah. So hello, Mridal. It's me, Shomobrata Bhattacharjee from Mechanical Engineering Department. So let me just repeat the question because I believe Ashok is having some network
Yes, sir.
issue.
Yeah.
So am I audible to you clearly?
Yes, sir. Yes, you're perfect.
Okay. All right. So the question goes like this: that what are the advantages of Circuit Python in IoT?
Okay, circuit Python.
Yeah, Circuit Python.
Okay, so like you are asking about a Python programming language.
Sir, the question says, I believe there is a library in Python known as
Yeah,
Circuit or something.
circuit
So,
Python.
yeah.
Yes.
So, what is the advantage of using Circuit Python in IoT?
So basically, like it's a library. Like basically, where this I have used it in Raspberry Pi. You must have heard about Raspberry Pi.
Yes.
So yeah, so circuit Python. It's actually basically it's a simplified platform of circuit Python. So whenever you are using some remote devices, okay. So remote devices like sensor data can be collected and it can be uploaded to a cloud, and it may like circuit Python makes it easier for you to access the data, right? Then
Okay.
next thing is like it's very easy to create. Advantages like easy to create, and like if you are a beginner, then you can actually easily start with it. Okay. Then like if you want to do some debugging, or if you want to do some kind of update in the code, so it's easier for you to do in circuit Python. Okay. And as well as serial console, which is there. The serial console, that's REPL, that is also very simple in Circuit Python. So there are a lot of advantages, right? Then it also comes to like storage, file storage. The file storage also, is a little bit, it's more, and you can incorporate more things and more data in Circuit Python. And the most important thing is it can support strong hardware. Strong hardware, like see, whenever like your coding and your programming needs to be changed with the like along with the hardware. So the circuit Python actually can handle a very strong amount of hardwares and drivers and sensors and breakout boards as well, right? So these are some advantages.
All right. Thank you. So,
Thank you, sir.
I, Ashok, would you take over?
Yes, sir. Mr. Hiran asked. The question is, can you hear me now?
So yes, but your voice is still breaking a bit.
Uh, can you please help me?
Yeah, sure.
Okay.
I
You
do.
can even type, sir.
Yeah.
So, let me take another question. So, and this question is from me actually. So, I want to read out my
Okay, sir.
question.
Yeah.
So, my question is that Python is used extensively nowadays, but it is incredibly slow. In fact, just a few days back, I was doing one simple coding in Python, and after running my laptop, which is a quite a powerful laptop, for almost 9 hours, I had to terminate the process and to shut down my laptop. It's a quite a powerful laptop. It has got an extra cooling system and all. But after that,
Okay.
I had to shut it down because it was taking too much time. After 9 hours also, it was not giving me any result at all.
Okay.
So my question is Python really used in the industry, or is it just used in academic research as I do?
sir, Python is actually not only in education sector; it's also used in commercial. Like it used for commercial products. I have myself worked on many projects where, projects where like 80% of the things were done on Python. So, and so you were facing problem in updating your software, is it?
Yes,
Okay. So
the response
sometime
time
like
is too slow.
okay. So there might be some errors because in my 6 years of history, I have been using Python for like 3 4 years, 4 5 years. So like I haven't faced any such situation like where updating the driver, I mean the software. So maybe, but like many people face problem in installing, and there are some errors which are called stack overflow error, but they do not. Uh, cause when you are updating it, they cause that problems, those kind of problems are caused while you're coding, or maybe you're uploading the code, or you're maybe doing some parallel simulation with some hardware. So basically, it should not take 9 hours. So
Okay.
maybe there were
No,
some issues with the
I was
connectivity or some system.
no, I was not working on robotics. I was working on something related to data analysis.
Okay, data analysis, all right. So you were
So
updating the software and it was taking like too long
yeah,
to get started.
too long. And
Okay.
yes, sir.
Mhm. So
Should
basically, sir,
I?
yeah, you can do one thing. Like you can, if it's still like if the problem is still persisting, if you're still having the problem, what you can do is you can uninstall the Python. You can get the latest version. So that is what I can suggest you, because this is something that I have heard for the first time. So you can go for the latest version, and like there is no other no other things that I can suggest you at this point of time. So you can try doing that. Get the latest version, get the older version uninstall, and sometimes it happens because of the stack overflow. Maybe maybe you have done lot of coding in that. Have you done, sir? Have you done a lot of coding in the software, or you have been
I
using it for a long time?
for almost 1 or 2 years. Yeah.
So you're using the same version.
No. Right now I'm having 3.7.7.
Okay. Then though it shouldn't actually cause the problem. So, but there sometimes it error like cause that's called PIP errors also. But so what I can suggest you is just you can uninstall or install it once again. And if your system is actually a strong one, then it should not have any system issues, so far as I know.
Sure. Sure.
Okay, sir.
So, sir, I guess we are running out of time. So, just I let me conclude it. And,
Yeah.
sir, really, once again, I thank you. We look forward to have more session and interaction with you. Thanks a lot for joining us today. And I express my gratitude to our Honorable Vice Chancellor, Professor S.P. Singh, Chairperson Academics, Professor Alok Kumar Buragohai, Registrar Ms. Angira Mimani, uh, Professor Dr. B. Banerjee, our patron, and the head of the department, Dr. Abhijit Deka, and my fellow colleagues. Lastly, I thank all the participants for actively taking part in this webinar. With this, we conclude our webinar today. Thank you all.